second dose way India no always second dose ఆరో లేకుండా కదా సాయి స్టూడియోలో ఉండదు షటర్ 50 పెడితేనే ఓకే కదా అది ఓకే
or most of the developed countries, a big energy consumption is happening within the houses. Okay? It means within the communities. So, how these communities or households can contribute in energy efficiency, demand side management, integration of renewable energy sources within the built environment. For that, what type of opportunities are available, that we have to see. We know that maybe not in our Indian condition or in tropical conditions, but when we are living in cold climatic conditions, we have very heavy energy demand within the houses for our survival. And most of the equipments within the houses, they are electrified and they have the capability to operate as per the input signals using IoT computers. Is it okay? In Norway, 100% houses, they are connected with the smart meter. Okay? It means that utility companies have all our information in real time how our energy consumption is happening. And that information to this smart energy meter is communicated to the utility company using inbuilt EC. Generally it operates on the 4G or 5G. So the data is communicated instantaneously in real time based on your real time energy consumption within the houses. Market plays very important role. So that work is also there, but we have the limited time and I'm also retired also. So with this energy consumption patterns and which have been collected in the real time, meter using eSIM inbuilt in the smart meter, the utility or energy supply companies, they decide the real-time energy pricing or forecasting of the real-time energy pricing for next 24 hours. So if we see how the energy price is going to be there for next 24 hours, I will show you because it is in my mobile. So customers on our mobile or on our applications, we get the idea that how the next 24-hour real-time energy pricing will be there. Sometime the energy price goes very, very high. Sometime it goes very low, and sometime, depending on the renewable energy prediction, especially from the wind turbines, for some few hours, maybe in a week or maybe in a month, electrical energy price goes negative. Means that when we are negative, we get paid more if we consume more. Okay? So now, my objective is here, everything is interconnected. And that situation will come in India also, maybe after some time. So how these communities are going to play the major role in contributing towards the energy efficiency and at the same time reducing the energy bills also. So with reference to that, I am going to present you some groundbreaking approach on energy management within the household, so that they can participate in reducing the energy demand and operating through virtual power plant approach, in which we need to use multidisciplinary approach. Is it okay? So this is a very interesting work now. Now what I mentioned you, when each and every house is integrated with the smart energy meter, which is in a position to collect the real operational data, it means that we are going to use information and communication technology infrastructure, which is going to play the major role on developing some scenarios for shifting the operation of residential. Because we are trying to have household participation through the virtual power plant, we want to use ICT infrastructure. For that, technological, scientific and commercial breakthroughs in demand response in the residential sector, how we can do that. So, here I mentioned about enabling household to participate. How they will participate? Through the smart meters. And everything has to be automatic now. So, if we take cold climatic conditions into account, then those houses, they are built up with high quality, thermally insulated. There is no leakage of the energy. Every house is having heating demand. Of course, other demands also. For example, electric vehicle charging demand, washing machines, dishwashers, cloth dryers, etc. And all these system components or the appliances which I am mentioning, they are in each house. Even the poor person, even the poorest person, he is also having these appliances in his or her house. And even poorest person is having a house which is thermally insulated. Okay? Otherwise, one cannot survive. Outside the temperature sometimes drops -10, -20 degrees centigrade. So people will die. So for our survival, especially in that area, the houses, that standard is there. Otherwise, no one will be allowed to live in those houses if those houses are not certified having thermal insulation. So it means that those houses are going to have very high energy consumption. Right? So this high energy consumption we need to manage, right, for reducing the energy bill as well as reducing the peak demand on the industry. We will show it, we will study this system. Just I'll give you a little bit background. In Norway, in last 1 year, the new cars which have been sold into the market, 100% cars were electric. 100% pure. Okay? And if you see on the road, okay, around 60 or 70% cars are pure electric. Every electric car is having the energy capacity of from 60 kilowatt hour to 80 or 90 kilowatt hour. So if you can see, it is a very high demand. With one complete full charge of the electric car, let's say if it is having 80 kilowatt hour capacity, it can go up to 400 to 500 kilometers depending on the climatic condition. In ideal condition, it can go up to 500 kilometers. In winter, maybe 400 kilometers due to the utility demand. So now, when every house or when we have seen looking on this factor that we are going to have a lot of electric vehicles, so most of the people, they will charge their electric vehicles at home. So that charging demand is going to be there, and that charging demand we need to manage based on energy pricing, based on demand profile, that we are going to study in today's lecture. So here you can see that how these utility companies, when they are collecting the data from the smart energy meters, how they are using that for developing next 24 hours energy pricing scenarios for making the profit as well as taking into account how the will change considering the constraints on the distributed network, then how they have to reduce by providing pricing signals to the customers, and accordingly then users, if they want to save the money, then they have to do the demand side management scenario, and for that then we need to utilize information and communication technology. So here you can see that how this multidisciplinary approach is going to be there. So for that, we have to utilize, or maybe if I go back on the previous slide, in the previous slide it was said that virtual power plant approach. If you remember correctly, that word was there. Virtual power plant. So from a virtual power plant point of view, considering centralized approach, right? So when we are having the group of houses or the group of loads, then that virtual power plant has to utilize the scalable infrastructure or the aggregation of the household appliances energy consumption. So how we are going to do that? That we will see. Okay. So for that we need to have large scale aggregation of households. So from the virtual power plant point of view or centralized operation point of view, this large scale aggregation of households is going to enable them to contribute towards the demand side management using some programs. So how we have to develop that programs, that we will study today. Okay? And for that, then I will need your active participation also. And for that, it is not necessary that you should have a particular engineering background. You will need multidisciplinary engineering background. Okay? ICT infrastructure, aggregation, forecasting, statistical analysis, and on top of that, energy economics also. So we will see that how we can do that. Now, in every houses, we have some critical and non-critical loads. Okay? Critical loads, for example, lighting, cooking, refrigerations, etc. Those who cannot shift. Only the non-critical load with inertia, that is again very important word, non-critical load with or having inertia, they can be used for shifting the operation or managing the energy consumption, considering user behavior and user preference. That's why this point is very important. Non-critical load shift. We have to focus on how intelligently we can shift the operation of non-critical power-intensive appliances, minimizing disruption to homeowners while maximizing grid benefits. This sentence or this statement, it looks like a pretty simple, but it has a very big meaning when we want to implement such type of system into the field. Okay? And then, when I am talking about the virtual power plant and to use the information communication technology infrastructure, okay, that is a well established in every country, right? So for that, we have to use centralized demand management approach. So how it works? Centralized approach allows the creation of or development of demand response scenarios, okay, centralized based on the aggregation of loads, and then communicate to the users, right, for doing energy efficient load shifting across the network, okay, so that we can reduce the peak demand, okay, because our distributed network is aging also and it has limitations also, and now we are going to have more and more loads, for example, electric vehicles and etc. So all these key aspects, if we have to cover, then what benefits we are going to get? I am just giving you a very high level information to create your interest, how we have to utilize ICT infrastructure for demand side management for aggregation of households or maybe aggregation of industries also it can be done. So the benefits of that is going to be for the grid stability, that will help us in doing the aggregation of household energy flexibility. This word is very important here, flexibility. What does it mean by? It means by shifting the operation of non-critical power intensive load in the flexible manner. What contribution? Towards the grid stability. Okay? So we can enhance the lifetime of our energy system network and more sustainability. So of course when we are doing that one, we need to have some cost saving or incentive based energy pricing. So we need to provide some benefits, right? Then only the people will participate, otherwise no one will care. So cost saving, how it will be done? Participating households can benefit from lower energy bills by adjusting energy consumption during peak demand period. Now, sustainability. So, when we are talking about increasing the lifetime of the grid, using the energy flexibility of the households within the distributed network, okay, so we are contributing towards the grid efficiency, and then here we are talking the flexibility. So flexibility will also help us to have the more integration of the renewable energy sources, so leading to more sustainable energy future. So now here you see how we are going to utilize in this typical case. I am going to explain you information communication technology infrastructure for this benefits, taking into account scalable aggregation of household energy consumption of selected non-critical power intensive. So you got the high level information now. So first I will skip this one, then we will come on this one. No, not this one. Yes, we will start now. Okay, so now here I have given you very high level information, and considering that high level information, I have worked on one European Union project, that is EU FP7 project, in which the idea was that to utilize information communication technology infrastructure for shifting the operation of non-critical power intensive load using some incentive based demand response program. So when we are having here group of houses, so this group of houses is basically going to be connected to the network. These group of houses, they are going to have different appliances, non-critical, critical also, and their consumption is going to depend on user behavior. And here we are going to have n number of users. Correct? So from the network point of view, it will be treated as one load. It means that this network has to take into account the aggregation. That's why this word is here, aggregation. So, how it works and what is the objective behind this one? As I mentioned that these houses, they are connected with the smart meters. And these houses through smart meters in real time communicating energy consumption profile using, let's say, ICT infrastructure. Basically it is using 3G or 4G eSIM inbuilt in this smart meter, and that data have been collected by the utility. Right? So the utility has the information, aggregated information of all households within that particular area. Okay? So that aggregation of the loads, using this ICT infrastructure, okay, how they can contribute towards what? Towards managing the electricity consumption of the household. It means that with reference to that, with objective of managing energy consumption, to manage this energy consumption, it means that to reduce peak demand on the network, so that our system can operate more energy efficiently and have more sustainable operation of our. Considering all this background into account, while working at the University of Agder, Norway, I have taken the lead as a technical manager for developing this project titled as Scalable Energy Management Infrastructure for Expansion of Resources. And this proposal, which we prepared, we submitted to the European Union Framework 7 for this copy. Some of you may be aware that whenever we want to make any project application for the competitive grants within the EU, we need to have minimum 3 European countries as a partner. We cannot work independently. We have to do the partnership with other European countries. Right? So, we thought here we are talking about household appliances and especially cold climate conditions. So we selected Norway, Switzerland, Denmark and Germany. So these 4 countries, they participated in this project. I will explain it, right? So then you will get the idea how the complete system is going to work in multidisciplinary approach. And with reference to this call, the objective was that here you see, use of information communication technology for what purpose? For low carbon economy. So now you see, ICT for low carbon economy, that is a, let's say, high level keyword of this call. And then you see how we developed the proposal, taking into account so that it has to be innovative also, we need to get the funding also. So why not we do like this, right? And of course, houses are built with the smart meter, they are with the ICT infrastructure. We can do the aggregation and we can use this ICT, right, managing the energy consumption. So basically towards the low carbon. Is it okay? So based on that, you know that when we are talking about incentive-based demand response program using ICT infrastructure, for the selected non-critical power appliances, doing the aggregation and shifting the operation also. So we need multidiscipline approach for that. Only one discipline cannot. Then when we want to get the grant from European Union, always it is required to have the technology readiness level of the project very high. Now here I use the word TRL. I believe that many of you may be aware about that. So when we do the research work within the lab environment or within the academic environment, generally it is at the TRL level of 1, 2, 3, something like that. But when we are talking about the TRL level high, around 7 and 8, it means that we are in a position to demonstrate that technology into the field, and based on that the industry can take forward and do the mass level production of such type of system. So that TRL level is very important when we want to get the funding from the European. So, and here we are talking about this aggregation of households using ICT infrastructure, and we want to improve the TRL level, right? So naturally we will require the industry partners. We cannot do the work without industry partners. Okay? So now we have the all complete idea. Most of the technologies, they can work very well independently, but the big challenge is to integrate them using ICT and IoT based devices and getting it implemented into the field, because we are talking about the TRL level of 7 and 8. So to get implemented into the field, universities or the research organization cannot work on their own. Right? So therefore, these partners have been selected to contribute in this project so that we can have the TRL level around 7 to 8 in this project. Then you can see here, we have partners from 4 European countries: Norway, Denmark, Switzerland, Czech. I will explain you that also, because this is really going to help you in thinking you out of box also, not from the academic environment point of view. So here, out of 12 partners, there were only 3 university partners. Remaining partners were the industry. Right? So you have to see that then to get the participation from the industry to participate in such type of projects, right, with objective of use of ICT infrastructure for low carbon economy, high level, but then coming with more focus towards the shifting of the energy consumption profile of the selected non-critical power intensive loads, right? So public participation is there. So based on that, then the remaining partners have been selected. When we are talking about taking the information or use of smart meters here for shifting the operation, we need to have participation from electrical energy distribution company. Otherwise we cannot do. So because we are talking about the TRL level 7 or 8. So that's why here from Norway we selected the Agadir Energy Net, which is distribution company, generation and transmission company of Southern Norway, because my university is in located in the Agadar province in the south, and we need to have the participation from that. Similarly, we thought to consider same system under different climatic conditions, that is in Switzerland, right? So from Switzerland we have selected the net plus, and in Alpian, okay, and then SEIC Teledis also, which contributes to have the active participation of the users for shifting the operation of this non-critical power intensive load with user participation. Now, you got the idea that when we are talking about European Union project with multi-country partnership with high TRL level, so based on our project objectives, how we have to identify the industry partners and how we have to convince them to be a part and how they will get benefit is a big challenge, right? So considering all these points, you can see that how challenging it might have been to identify the partners to be the part of this project. Then we mentioned here the ICT infrastructure is also going to be there. So this ICT infrastructure, because we cannot build, we need to have the participation from operators also who is running the communication network in that area. So Net Plus and SEIC Teledis group, they were running the communication platform in the Switzerland, but Agadar Energy Net, it has its own network because they put the SIM here, eSIM, and they were collecting the data themselves, right? So that Agadar Energy Net. Then of course, we are considering about the virtual power plant also, because many of you are from computing background. You know that how the data it gets collected to a server. So not only from the collection of the data, but in this case, we are collecting the energy consumption profile from these houses, distributed, and getting it aggregated at the virtual power plant or the backend system or on the server, and there we have to process this data. Okay, for what purpose? For low carbon economy or shifting the energy consumption profile. It means that, and for that we need some appropriate algorithms also, and for that we use Fraunhofer from Germany, because they have already well established facilities to process the data which have been collected from these houses and do the analysis, and considering grid constraints, available capacity from conventional sources, using virtual power plant approach to provide further output. I am going to explain that also. But now here you can see that how the partners they have been selected for this project, and the outcome of this project, or the objective of this project, is very, very relevant to the key focus of our campus. Because in the campus we are talking sustainable technology development, machine learning for the computing techniques, and for the computing techniques collecting the data we need the ICT infrastructure. So that's why I thought to share with you the working experience of this project. Is it okay? So after getting all these is information together. I will come back to this previous slide. We prepared the project proposal to the European Union, and to get the funding from the European Union, it is not easy. There is a competitive process. So under this all, there were 60 applications or 60 proposals were submitted from different European countries. Out of 60, only 4 proposals they have been shortlisted, and then we have the interview with the European Union, and 5 shortlisted and 4 funded. So among 4, this project. So you see how we have to develop the idea. So we had to convince the reviewers, experts also, why they need to give the funding to us. Right? So this project might have been rejected also. So then all efforts what we have put gone waste. But we were lucky at that time, right? So this proposal, out of 60, 4 proposals were sanctioned, and one of this proposal was there. And then you can see that the funding of this proposal, it was around 3.8 million euros. So it was quite a big. It's like when we want to do the research or academic work, right? Always in developed countries, we need to get the funding from external sources. And to get that funding from the external sources, now you can see that how competitive it is and how innovative idea we need for that. Then only we will be in a position to get. So it is not that easy. So now you've got
students who are staying in hostel for new programs. 4 rooms are staying, 4 different rooms. You pay. Then did you get the receipt? Can you send us the
next time जब तक चार्ज हो जाता है you can have one coffee break, okay? थोड़ा सा बंद करो. So shall we start now? So before the break and before having a problem out of battery, right? We discussed about that if you want to make a project proposal in which technology readiness level is quite high, so then how we have to identify the industry partners, how we have to define the objectives, so on and so forth. But now, coming back, the objective which we define as aggregation of households for using under the flexibility for using ICT infrastructure. So here in this slide you can see that here we have the customer domain, aggregation of households which can provide the flexibility and support to ancillary services with what target demand response of the selected non-critical power appliances, which can help us to integrate renewable energy sources within the built environment, may help us in identifying the possibilities for the energy storage also and distributed generation. So here you can see that within the customer domain, right, especially when we are taking the aggregation of households, how we can provide the flexibility. So this is the very interesting and important point here. But what is the objective? The objective is using the ICT infrastructure to utilize this flexibility by the grid or energy market. To utilize that flexibility into the grid or energy market, what type of signals or informations are going to be required in both direction, that is going to be very important. So that flexibility when the grid want to use, right, it needs to have the information exchange of status values, forecast and middle. Okay, and then that information energy system operator can utilize for developing price signal, providing some incentives and maybe the real-time tariffs to the customer domain, and also the control signals for shifting the operation of non-critical power intensive load. It means that flexibility is offered from the power system operator to the customer domain. So how it is going to happen? It is going to happen in real time when we are collecting the information from the customer domain to the backend system. Now here we have seen that the customer domain, they are in the field, in the condition, let's say it is a Norwegian condition, but this grid operator or this power system operator which need to provide the flexibility signals or the information to this customer domain. So here we need to have virtual power plant approach. So this virtual power plant approach in this project, it was based in Germany. So now you can see that how we are utilizing the information communication technology infrastructure for the flexibility, right, by doing the aggregation of the demands of the customer domain. And so this is a very good high level information about this project. Then when we move forward, of course we need to define the objectives of our work. So now you have to help me, what should be the objectives, because I have provided you with high level information, I have provided the high level information about the partners, identified partners, and what is the objective. So considering all these points together, the aggregation framework for scalable energy management infrastructure for aggregation of households, these 7 objectives have been defined. And these, based on these 7 objectives, the work package or the task related to this project have been described, which I am going to explain you step by step. First objective is technical and functional design. What does it mean by technical and functional design? So the first objective, that is a technical and functional design, it means that when we are having households, aggregated household, we need, right, to provide design for technical operation and functions of the components which we are selecting for participating into the demand side management, and especially the non-critical power intensive load. It means that we have to identify within the houses, right, because we are doing the aggregation, what loads they can participate in this. So do you have any idea what type of loads can be selected from the houses which are at cold climatic condition? So in this project we identified boilers or the thermal inertial loads, because they have the inertia and non-critical loads also. So their functional design and technical operation that is going to be required, that have been considered in objective 1. Second objective is ICT infrastructure. It means that the energy consumption profile of the selected load, in this case it is the thermal load or the boiler load, we need to collect that information. So that information has to be processed locally as well as at the virtual power plant also. So to operate that load, we need the operational characteristics of the thermal inertia load, that is the boiler, minimum maximum operating temperature, power consumption profile, user consumption profile, etc. And those profiles need to be processed at the local within that home and then communicated back to the home energy management gateway, and to make that communication between home energy management gateway, let's say that we can call it as a smart meter, and the virtual power plant, we need to utilize ICT infrastructure there. We are not going to develop the new ICT infrastructure there. Then at the same time, when we are processing that information within the house from the boiler, right, so that device should be IoT based, or that device should be in a position to communicate all the information of energy consumption, temperature profile, and the load consumption profile also. That has to be communicated from that device to this home energy management gateway using Zigbee communication, what we used here. So you can see that in objective 2, how Zigbee communication and 3G or 4G communication, they have been used, and based on that, the second objective of the project has been defined. Okay, it looks like a very simple objective, but if you want to work in the real project, when it has a technology readiness level around 7 and 8, it is going to be very complicated. Okay, I have all those models with me, but I don't want to make boring to you to do all these mathematical equations of the boilers and like that. So, but then next objective, that is the key objective of this complete project, that is on development of aggregated intelligence. So that development of aggregated intelligence is like that. When we are collecting the information of selected non-critical power intensive load through Zigbee communication to the home energy management gateway, and then that home energy management gateway is communicating that information to the virtual power plant by using 3G and 4G communication, and then this virtual power plant then process all this data in aggregated manner and develop the demand side management scenarios by taking into account not only the user behavior or user preferences, but also taking into account the limitations of the distribution and the feeder load. And then those information or the signals are communicated back after developing that demand side management scenario, which have been considered here in this objective 3, back to home, back to this home energy management gateway, and then this home energy management gateway, that signal communicating to the boiler in this case for shifting the operation, and everything has to be done automatically. So you can see that how the data collection with specific parameters have been used with technical parameters, right? Then based on that, taking into account the grid constraints, then that demand side management scenario has been developed at the backend system, that we call it virtual power plant, and then that has been communicated back to the home energy management gateway, and home energy management gateway is communicating that signal back to the device through Zigbee communication. That have been considered here in objective 3. So I was leading this objective 3. Me and my student, we worked very hard on this one in developing this algorithm. One was using decentralized manner and another was centralized manner. Okay. Then next objective is integration of front end and back end system. So I was mentioning two words here. One is home energy management gateway and next is the virtual power plant. So the home energy management gateway, it was the size of our mobile, it was within the house and it was using an appropriate operating platform also. So we have to integrate this home energy management gateway to the backend system, right, that have been covered into the objective 4. Okay, I will explain in much more detail, but now I am defining you the high level discussion what we did. Based on that, how we have to refine the key objectives of the project. Then what we discussed earlier, we have to do the pilot testing to justify the technology readiness level at 7 and 8. That have been covered here in the objective 5 for pilot testing and validation. Pilot testing means the system which we are discussing here, that home energy management gateway and its integration to the backend system, it has to be implemented into the field, right, that we call it pilot. So we selected 100 houses from Norway and 100 houses from Switzerland. Okay, and then that have been implemented, that have been covered into the objective 5. Then the objective 6, which is a very interesting and important here, that is a security and privacy. Because when we are shifting the operation of non-critical power intensive load, we have to respect the user privacy also. So others should not know that what load has been shifted of that user also. That have been covered here. And then of course, when we are communicating the data, we have to consider the security of that. That have been covered into the objective 6. And then when we are having such type of system of demand side management within the houses or within the distributed network, naturally it is going to impact the businesses of utility company for revenue generation. So in objective 7, we consider the development of new business models. So it means here you can very clearly understand the objective is very simple of this project, but when we want to implement that, how critical it is going to be there. So if here you see, the objective is that if suppose we have a typical load profile, it is like that, we want to shift the peak demand to the off-peak period, okay, and it may be on the real-time basis. So to improve the load factor of this curve, that is the overall objective. But if we consider this overall objective or high-level point, then it looks very simple. But when we want to implement that in the field with TRL level 7 or 8, then we have seen that how complicated it is going to be there. And in that, then how we have to utilize the multidisciplinary approach. So let's come to the front end side. Front end side means homes. Within the homes, we have this home energy management gateway, that is, let's say, is the size of the mobile, and every house or the selected 100 houses in Norway and selected 100 houses in Switzerland, those houses, they have this home energy management gateway, and on this home energy management gateway, OGEMA platform have been used, and that OGEMA platform have been provided to this project by the Fraunhofer Germany, and that OGEMA platform was in a position to communicate the information or the signals which received from the backend to shift the operation of non-critical power intensive load. So that is based on the IoT basically. Okay. So here you can see that how we are doing taking into account the shifting of this individual household appliances in aggregation manner, right? For what purpose? For improving the load factor or shifting the load. So I believe that some of you are from communication background, so they may be aware that how the Zigbee communication works and how the 3G or 4G communication dedicated bandwidth have been used for communicating the data from front end to the back end system. Do you have any idea here or any question, any point? Now next point is we come back to the back-end system. Back-end system is the virtual power plant which collect the information of all aggregated households. Here you can see all the information. And on the back-end side, we have the information of renewable energy production also. So here you see that renewable energy production information, renewable energy production and their prediction information is available at the back end, and that we call it as a virtual power plant, and all this group of individual houses are providing that information to home energy management gateway to the back end system, and here we are doing the aggregation. Now based on the information which have been collected by the back end, that we can call it as a virtual power plant, then this virtual power plant can generate the demand side management scenarios which can, based on all these parameters available, by giving the priority to the renewable penetration, and then that demand side management scenario, here you can see that I mentioned the demand response communicated to the selected houses, right, through this 3G or 4G communication, that we call it front end, and then it has been shipped. Is it okay? Now here you can see that it has been mentioned security and privacy management, because we are doing all this real-time communication of the data, right? So we have to be very careful about the security and the privacy also. And within Norway, if we take that condition, it is quite easy due to every house, every energy meter is smart, so they are communicating all the information in real time to the backend system. So here, maybe you can, from your interest point of view, you can think like how the integration of front end and the back end system is going to be there for doing this simple operation of the demand side management. Is it okay? Now, what the benefits which we are going to get here? Now here you see, so now you can see here, we are talking about the demand response system. We talked about the front-end system. Front-end system, we have the home energy management gateway. Back-end system, here we have the aggregation. So aggregation of all these loads, right? Not only the aggregation, but based on the information of the load consumption profile of the selected loads as well as the overall loads, then here this back-end system is in a position to do the forecasting. How the forecasting of the loads is going to be there. But at the same time, this back-end system or the virtual power plant has the responsibility to operate the distributed network within the limit, means every feeder, every network lines, they are going to have their capacity limit. So that capacity limit also need to be considered by the back-end system, right, while developing this demand side management scenario which need to be communicated to the front-end system. And for that, of course, we need this wide area network also. So here you can see that for this simple application of demand response system, when we are trying to utilize this centralized approach, how the communication network is going to play, that let's say we call it as a wide area network. Now, the benefits of that, distributed system net users is also going to get some benefit, and customers also going to get some benefits. So let's say if the customers, they are going to get the benefit, what the benefits will be there? Customers can monitor their load profile, how it is happening, right? And customer can have the information that how their data have been collected and provided from the front end to the back end system, as well as based on that customer can also consider that how much energy bill saving will be there, but most of the benefits will come to the DSO and TSO. So what the benefits of the TSO and TSO will be there, they can work on energy management system, and that energy management system due to the virtual power plant will help them to overcome the fluctuation of renewable energy sources and to improve the grid functionality, right, for doing energy efficient operation, and of course the collected data will be used for further planning of energy network. Now, I have given you some information, objectives, how the system works. So based on that, this project or this work have been divided in different work packages also. So here, first work package, it was related to the project management, and my role in this project, it was as a technical manager. And now here you can see that how the 12 partners from 4 countries with user participation and the pilots, how technically it is challenging also. I will explain you what technical challenges which we do. In work package 3, we did overall system design and specification. In work package 4, we did development of system infrastructure. In work package, we did development of aggregated intelligence. In work package 6, system integration. Work package 7, pilot testing and system validation. But at the same time, whatever the results which we are going to get, those results which we need to disseminate to the stakeholders and the common public also, because there is a public participation and this project is funded by the public money. So we need to have exploitation and dissemination work package, and to have the regular engagement from the stakeholders also. Okay. Then it is very important that all this we are using the ICT infrastructure. So work package 8 covered the system safety, data privacy, user privacy also, and going to impact the business model. So it has been covered into the work package 9, how we have to develop the new business models also. Now I am going to give a task that based on this front end and the back end system, right, how you will develop integration of both, what data have been collected from the front end system to the back end system, and what data have been provided from the back end system to the front end system. So I am giving you, let's say, 15 minutes time, and please prepare one flowchart or architecture where we need to integrate front end and back end system, right? So after 15 minutes, then I will share you the system architecture, how we develop and how your thinking are getting matched with that architecture. Okay? So now please have 15 minutes time, right, to develop the architecture. Maybe I should go back here, in which we are trying to integrate this front-end system and the back-end system. I'm not asking you to develop some programming, because it is very difficult to do the programming at this moment, because we are having so many different components, okay? But at a very high level, if we have to develop the system architecture, and I believe that most of you are quite very good in that one, because you have the many of you have the computer engineering background. So considering this slide into account, how you will develop the system architecture for integrating front end and the back end system. Those who are sitting back, maybe it may not be visible for them, maybe they can go front and take the photo, or maybe just go and read that and then work on developing the system architecture for 15 minutes. Okay, then I will share with you how we develop that one, because your participation is also very important. I will provide some little bit information also. So here we have home energy management gateway. Okay, so this home energy management gateway in selected, let's say 100 houses in Norway and 100 houses in Switzerland. So that home energy management gateway, it is working as a bidirectional. Okay, and in this home energy management gateway, collecting the information from selected non-critical power appliances which are going to contribute in the demand response program. Okay, then that information from this front end system is communicated back to the back end system. So back end system, that is a virtual power plant. In that back end system, we are collecting the information through this home energy management gateway from the individual, right? How the load profile is happening, how the consumption profile, not only the selected loads, but overall also, because that overall load profile is also going to be useful for developing demand side management scenario. And then that information what I have mentioned here, then it has to be aggregated here. Based on that aggregation, right, then of course this backend system has to take into account some constraints. Those constraints will be feeder level, distribution level, because we cannot change the demand above the limits, right? So some specification of the limits is going to be there. But at the same time, if we have some renewables here, so renewables is going to get the top priority also. But then accordingly, this backend system or the virtual power plant system has to take into account limitation of the conventional power plants also. Okay, all considering all this information based on the forecasting techniques, then this backend system is going to generate some demand side management scenario. So then that demand side management scenario is going to be communicated back to this aggregated loads of that area. Okay, and then it is going to be used by this front end system in shifting the operation of the loads. So this demand side management scenario which might have been generated this backend system, they may valid for next 25 minutes, 30 minutes or 1 hour, and at the same time then that information at the backend system based on overall energy consumption profile and like that can be used by DSO in generating real-time pricing signals for next 24 hours also. So then that next 24-hour price signals is also going to be useful in the front-end system for shifting the operation of non-critical loads also. Then user can decide or put some preferences also. So now considering all this point into account, and taking into account your background at the postgraduate level, I expect that you may be in a position to provide me some system architecture. Okay, don't worry about that, how you will make it. Okay, try, and then I'm going to share how we develop the system architecture for that.
They told the police by now by afternoon.
And when we are talking here in the front end system, here I mentioned sensors, actuators, etc., etc. So those points are also very important, because on the front end system, when we shift the operation of the selected non-critical load, okay, so let's say in this case we have the thermal inertia based load or the boiler load, so that operating parameters of the load is also going to be important. So what are those operating parameters? For example, minimum and maximum operating temperature, because always that thermal load we have to keep it at the minimum temperature, otherwise that boiler functioning from the health and safety condition point of view will not be good. So that just I have given you one example. If in case of boiler, if we select the electric vehicle charging load, so we have to see that how we have to put the minimum reserve charging also. So all these points I want to see that how you can include in your system architecture, okay, for developing such type of system. So in this project, we have taken the typical case of the household appliances, but the same thing can be used for industrial applications also. Two of my PhD students, they are using the same approach for industrial application. One student, he has completed his industrial PhD in shifting the load of supermarket store, in which we have both critical and non-critical loads. Then he used thermal storage and the battery storage, integration of renewables also, and he used machine learning algorithms for developing the scenarios for shifting the operation, and his PhD thesis is publicly available. Okay, I will share that thesis with you. And then one student, he is still continuing his PhD work, but he already published some paper. He used the scenario of the industrial case of cheese factory. Like in the cheese factory, then we have the both critical and non-critical load, mainly the thermal load and the cooling loads. And then he used physics-based modeling for shifting the load. And the earlier candidate, which I mentioned that he took the case of industrial supermarket case, he used machine learning based approach for demand response system. So now here, what the task which I have given you for this typical case, how you are thinking based on the lectures or based on the discussion, right? How you will develop the system architecture for that one at very high level. If you need any inputs from my side, just ask me, okay? We are working on, let's say, real time for the daily basis. And let's say we are taking the urban area. Urban area means the houses which have been selected. We can say urban, rural, whatever, like, depending on the current conditions and locations. And those houses or those cities, they are participating. So basically, our objective is on the demand response system. And within the demand response system, if we go back here, our objective is improve the load factor, shift the operation. And to shifting the operation, we want to use this domestic. So all the loads we cannot shift. We have to select non-critical but power items. So that we need to identify. That we at the standard system. But you see, daily or all the time the curve may not be like this. Because we are having the real-time pricing also. And we are integrating the renewables also. Correct? And we have, renewable has to get the petrol. So this is going to be the dynamic. So that's why we use word non-critical. Right? So this, and then here, that information there, let's say everything should be automatic. Otherwise it will not work. So then, based on that, how then we have to take into account the constraints of the load source. And then all this information then in aggregated manner collected at the backend system. You see, for all houses in one unit. And then this backend system, that's we call it as a virtual power plant. Then, based on this one, of course, real-time collecting, and it has a historical data also for Lex Classic. Based on that, may get the information about the forecasting also, how the load may vary. Then may get the information of the forecasting of the renewables also. Then, okay, and then of course conventional power plant production and information will also be available here at the virtual power plant. But then when we have the houses here, here's the information about the capacity of these lines also. So that also need to be taken into account. Then based on that, this backend system will create some demand side management scenarios for next 1 hour or 2 hours, whatever. And then that will be communicated back to the backend system, to the home energy management gateway. And then this gateway is going to communicate to this local load. Right? So you see, of course, no, we have to think from the system engineering point of view always system. Of course, no, weather parameters is going to impact renewable prediction.
In terms of renewable, you have to think about weather parameters.
Then other parameters is also very important that we will consider cover maybe in the next lecture or something. So that weather parameter is going to impact the energy consumption profile of this process also. Correct? Because if we are taking that house as a load, so inside how much heating demand is going to be required, that will be based on outside weather parameters. If it is too cold outside, we need more energy. If it is too hot outside, or basically the balancing, or accordingly the energy consumption profile will change. And we are taking the thermal load here, that's why. So thermal load is going to be based on weather parameters. With the, accordingly the energy consumption of it. So how, let's say, if you have given as a task of it as a system architecture, right, how you will develop that? You got my point? So, I mean, we can develop the modeling for each and every components. Okay? Then, when we want to develop the modeling for each and every component, then we need all technical characteristics, no? Operational characteristics and everything. Then it requires a lot of time, and then we have to go through the literature review and find out, or we have to refer the manufacturer's manual also to see anything. But now, because we are at the learning stage and high level different discipline, so system architecture I think it is much better. So let's try. Okay? So that may be your assignment. Maybe then you can say that yes, we participated into the examination. Okay? then we can say that yes, participants are participated in the examination also. It's up to you. Okay? If you want to. You can make maybe on one page, okay, or whatever you feel comfortable. Then it may be much better that Maybe you can work in the groups also, or maybe 2 people in one group or one, and then I will request that group or that person to share their ideas with the audience or participants also, what they think, okay? Then that will be more interactive, and then I will, yeah, okay? This is a typical example of this project is a typical example of our or typical case study, maybe I can say, for our course also. Okay, because our course is use of machine learning for sustainable technology development. We are trying to do the sustainability. We are trying to do integrate some machine learning tools and like that. Okay, and you are learning that one. So then we have to see that how you are going to integrate that and how your learning is going to be there. Of course, I am going to show you how we develop the system architecture. You can take maybe 15 minutes more time, but I am going to request as a group some people to present that what they thought. Okay? So then that will be much more interactive for me also and for you also. One more thing, depending on your thinking also, here when we are talking about this individual houses, okay? So here you see these houses, they may have the building integrated photovoltaic system also. So that production of the building integrated photovoltaic system is also going to impact the overall energy consumption here. Correct? So that may be impacting in deciding the demand side management scenario from the backend system here. So in your thinking at the system level, you can include that production of building integrated photovoltaic system, which is going to depend on local weather parameters. I mean, if we think overall this objective, it looks like a very simple objective, shift the operation. But when we want to do the implementation into the field using centralized approach with integration of the back end and the front end, how complicated it is going to be. interesting thing, when we are talking about here home energy management gateway, which is the size of the mobile, let's say, it is going to have its own operating platform also. And time to time, this operating platform, in this case it was Ogema, we need to upgrade also, right? As we always get our mobile software updates and so on and so forth, taking into account the security and privacy conditions, everything. So that functionality should also be there. I have to do the faculty interaction from up to 12:45, correct? So you can have the time up to 12:45, and I think by the time the lunch will be there. So then we will be having the lunch, okay? And then after lunch, we will in the home. Then we will meet at Homi Baba Hall, and in the Homi Baba Hall, then we will take forward how the system architecture should be there. And now you have enough time. So during that time, I want to have your participation or your thinking, how you think about this system architecture. So I will request the participants maybe to present their architecture for 10 to 15 minutes or 5 minutes, 10 minutes, maybe in the group. And of course then you need, this will be the good opportunity for me also to know your background and to know like in which area you are working also. So that is the plan. Is it okay? Is it okay with all of you? Are you sure? Very good. And then, yeah, you can be here till 12:30 or 12:45, okay? 12:30 and I may come back here at 12:45, okay? After the meeting, I am keeping all my system here.
2 p.m.
And we will meet at 2 p.m. in the Homi Baba Hall. And at 2 p.m., then let's say within half an hour or whatever time, then I request you to present your thoughts on the system architecture, and then I will present the system architecture on which we developed this system. Okay? Is it okay? Is it okay with the plan? Very good. Yeah. Thank you.
2 o'clock ใช่ไหมครับ
Participants did not receive the lunch coupons. So before one go to the lunch, because after lunch some other program is there, there will be like exam itself. So before one, I request everyone to take your lunch. Go early. And 2 o'clock, same in Homi Baba GIAN. You can come.
system architecture which you might have developed for such type of project, in which we want to integrate information communication technology, front end system and the back end system. Anyone who want to come forward? Please feel free. Yeah, please come. Yeah, please. So that will help us to understand how the participants, when they don't have the enough in-depth information about such type of system, how they think the architecture should be here. Yeah, please. You want to use document camera? You made some. Yeah, thoughts also, or if you made some diagram on the paper, okay, we can share that through this document camera on the screen also. Yeah. Don't worry. So whatever you feel comfortable, please. Yeah. Yes, please.
Good afternoon to everyone. Myself Yorani from M. Kumarasamy College of Engineering, Karur, Tamil Nadu. Actually, as per the discussion, what we have discussed in the past 4 days, so based on the understanding, I would like to share my thoughts. It's my perception. We'll discuss remaining things. Sir may discuss about the pros and cons of that. And here, I would like to share. The thing is, Sir has discussed about the energy storage system. That energy storage system is we may take that energy from the renewable energy sources. From the renewable energy sources, we are giving for utilization. That utilization, how we are going to predict in that aspect. Sir has given some overview about what are the projects he has worked. Here, I would like to share my thoughts as per Sir's knowledge. So, shall I get the another one slide which you have showed me?
This one?
Yeah, this one.
This one, we can do that one. You want to show? Shall I show you?
No problem.
Yeah,
Here itself,
yeah, it will come. Yeah.
the previous ones.
This one or this one?
Oh, sir, I want the previous one thing you have shared about the front end and back end. That slide I want.
That slide. This one, I think that might have missed here. Closed it, might have. We'll see it out very. I think that.
So shall I take it from my mobile?
Don't worry. We'll find out. Don't worry. This one? No.
This one.
Yeah.
Okay. So in this first thing, what you have to look at is the customer. Customer in the sense, here my understanding is, I have taken the example as how to predict the energy consumption by using machine learning. In that is my thought. Based on that thought, I'm going to present here. First thing is customer. What I have assumed is we are using see here in home automation or anywhere else, in that, I mean, energy consumption is in base that will be there in rural area as well as in urban area. The energy, if we are using here, the customer, I have taken the profile management and monitoring is for rural area as well as urban area, how the energy is utilized. That is that I have taken in the customer side, and then the energy, how much amount of energy it has been absorbed, I have taken the front end as home energy management. That can be sensed by means of sensors, actuators and meters, and those things will be those things will get the information about the consumption by the household in the household applications. With the help of those data, we have to get the nearby weather information, because the data home automation or whatever it may be, because we will be there in winter season as well as there in summer season. So because in winter season we may not use fans or air conditioner like that, but instead of that we may use heaters. So likewise we have to consider all the parameters. Along with that, weather data also you have to look it into that. All those parameters we have to take it as a data. That with the help of those data, we have to go for the next process as backend system. With the help of those data, we have to go for machine learning process. In that machine learning process, sir has explained number of things about from the starting of the data set, and how do we want to remove that. That means we may have some missed values like that will be there, and then how do we want to consider those data, and then how do we want to fill up those data, that missing values, those things you have to do, and then you have to go for aggregation and then forecasting. Here the forecasting depends upon the application how we are choosing. We may go for the data, live data, or we may take for 1 month data or 1 day data as like that. So based on that, the data set we may get it as live data, or we may get the data that means that stored data, like as the European countries have that stored data, we may get the data set from those data set, and those data sets we may use machine learning algorithms. We have n number of machine learning algorithms as are discussed. That algorithms we may implement, and from that implementation, and we may go for prediction analysis we have to do. So from that prediction analysis, we have to look for accuracy. That means which algorithm have given better accuracy, and from the overall assumption, we have to look at the main thing as in this. I have understand from this diagram is we may get the data in all the ranges, but you have to look at for the peak value. So where we got the peak value, so for that data we have to work out, and based that value we may obtain from the prediction. So based on the prediction analysis, we may look for the energy system also. Here renewable energy sources plays a major role, and which type of renewable energy we are using, that is also very much important.
She has briefed very nicely that how the different technical parameters need to be covered, and how the machine learning techniques can be used for this integration of front end and the back end system. Right, so maybe in simple way, integration of the front end and back end system, but for making the decision at the back end system, the focus, if I understood correctly, was like to use the machine learning tools for defining or predicting demand side management scenario, which need to be communicated to the front end for shifting the operation of non-critical loads. And in that point, she also mentioned that we need to consider about the renewable energy sources, because that is also going to be used into this flexibility component within the distributed network. Am I right? So anyone want to share? I mean, do you want to share something? Yeah, please come. Very good. So we can connect it your computer with HDMI. Okay. it is very important to have your participation also. Na? So how you are thinking, and then I will also get the idea that how you can work on such type of projects where we want to integrate, let's say, centralized approach for doing energy efficiency through demand side management. Okay, and then when we are using the centralized approach, then of course we need to use machine learning tools or AI tools for that. Please.
So, am I audible? So, based on my research and understanding, for renewable energy resources, I have made a small architecture, and it is based on my previous projects in my bachelor's and my master's, and till now whatever I researched, based on that, I have made a small architecture. So uh, as we all know, in future we are coming towards our energy resources are going to decrease day by day. So we are more focused towards renewable energy. So that's why I have selected few renewable energy sources as wind energy and solar energy and thermal energy and some biogases in my architecture. Like, so few renewable energy sources I have linked, but before this block, uh, how the interface should be to the user. There may be many renewable energy sources, but how user can interact, and as sir said in previous lecture that there should be virtual platforms to organize our work, and how the data is stored from the renewable energy sources, there should be virtual databases, so that remotely all the engineers and all the researchers can work. So I am starting from the diagram as user interface layer. So user interface layer, I added web portal, mobile application, or some voice assistant integration. Why? Because everyone have different backgrounds, everyone have different they can provide services from different locations. It is based on their convenience. So there may be many interfaces, but I have considered these three interfaces. So after interface, application, like in the core management layer, I added AI optimization engine and authentication main control system. So I want to elaborate this user interface. Yes. So real-time monitoring system we can do if we are based on how many data centers are there. Real-time monitoring system we can establish in any web portal or mobile application. And yes, we have to focus more towards we have to shut down entire system for the safety of the huge project. If not, due to the small error, the huge project will get many expensive damages. And yes, I'll come towards the next block, that is data management. Yes, data management. How we are managing our data. How we are after user interface, core management is there. After core management, we have to focus on our data. What particular data, like face detection system, sir, said that previously they are focused on eyes and what are the important features are there. So in data management for renewable energy sources, some important major data, time series database, forecasting system, and weather integration, analytics. Based on weather conditions, based on timestamps, based on how sudden the rainy season or sunny season is there, summer season. Based on that, we are categorizing the data and storing locally. So we can work out in virtual platform. So after data management, why we are focusing on more on data management? Because if we focus more on data management, more better results we can extract. How much detailed data we are gathering, we can do more research based on the data sets. How much detailed data we are extracting from upper sensors or any the extraction of data, we can do more detailed research and get more better results. So after data management, left side one block diagram is there. Yes, different energy storage. This is storage, this one renewable energy sources. We can consider I am more focused towards because doing research on that. There are multiple renewable energy sources, but I have done my project in ad hoc networks. How communication is possible in remote areas, in mountains. So that's why I am focusing towards wind energy system. So after renewable energy sources, energy storage systems. See, I have not make my architecture as, but superficial overview I am giving. I have not done like that research. Yes. So the wind turbines store the energy in their turbines itself. Based on that. So battery banks will be present in turbines itself. Battery management is there. How much data it support? Wind is not that much. It is not rotating the sun. So there will be some storage to push the turbine wind, wind initial to take initial start. So like this we can manage our battery life, like totally we can store some power that which can be supplied further into other panels. So next is home management. See, so home management system. Yes, home management. As we all know, nowadays in all homes AI gadgets are there like Alexa and whether it is chimney, whether it is our cooker, most of the things have AI integration in the gadgets, daily home appliances. So we can categorize how much power is utilized in different devices in home itself. And if we are completely occupied with the power, we can store it locally in home. So that inverters we are using now, like if we are collecting the data from renewable energy sources, we can store locally in our battery banks at home for later use. Yes, I want to conclude because at courses which are used nowadays, like petrol, diesel, they are getting decrease in a rapid way. That's to do research in renewable energy source, and I selected my topic as wind turbines. I have worked on wind turbines also. That's why I selected this topic. So thank you from my side.
Thank you, Amin. So, Amin try to give a very high level understanding in which we can have different renewable energy sources, energy storage, and then he also tried to consider about the user interface, okay, and then of course taking into account some smart gadgets which we can use for our home automation, and within that then how we can do the home energy management system. So thank you, I mean, so it's good attempt. Anyone among you want to present something, please? Yeah, please. Yeah, no problem, we can. No problem, no problem. Yeah.
I think these arrangements are not needed actually. Just fan beside me, it will be done. So we have two things here. One is power generated by power plants. Artificially, we are generating power with some nuclear plant or coal or combined cycle gas turbines, etc. And we have the power generation from the renewable sources. Based on the load demand, we can vary the power production at the plant. For example, if we are generating power at some renewable facility, power production done by the artificial or non-renewable source. So I think this form of architecture is better to, plays better role to optimize the power needs. Thank you. So that was a small idea how to optimize.
What's your name?
Rashid.
Thank you, Rashid. You provided a very good overview, and I can understand that. I mean, his enthusiasm and understanding of the complete system. What he provided at very high level, that to overcome the intermittency of the renewables, how we have to manage the conventional power plant, and for that, how this home energy management system, or maybe in a simple way, load patterns can also be modified accordingly. That is basically the key or high level theme of the project which I was discussing with you. And what Rashid was telling here with reference to the power plant and the renewables, I teach one very focused course, power system dynamics stability and control, in which I use this one. So when we have these conventional generators, so how we have to implement control system, PID controller for controlling the input flow to the turbine with reference to this intermittency. And then of course, we can get the prediction of the intermittency. Conventional power plants are there, but demand side management demands are going to be fluctuating. So we can get the opportunities for demand side management. So it's really good. Anyone want to present something? Please feel free. Yes, you want? Yeah, please. Very good. Yeah, then no problem. So you can put it. It's really good. I'm very happy to see that active engagement from the participants, because that is always good. No? Otherwise, it is just like a one directional information flow.
Good afternoon, sir. Thank you for providing me this opportunity. I thank Farooq sir also for conducting this event. Power management system, as you explained, I came to know that hydrogen power also plays a main role in providing power for households as well as for industries. I categorize power management system into mainly three, depending on location, season, and usage type. Usage type is nothing but household or industrial use. Depending on the season, the power usage will be varied at vast during winter season or summer season or rainy season. There is a lot of change in power usage, as well as depending on the location also. Coastal areas require different power usage, whereas the central regions need different power, and hill regions need different power usage. It's not that one power management system is created and it can be utilized for all centrally, for all locations, or for all the seasons. It should be changed depending on industrial as well as household. So I categorize this power management system that should be designed into these three categories. Now, in this again, we can use machine learning for making the decision which location we are going for, whether it is urban area, coastal area, or rural area, where you want to use it. In those areas also, depending on the season, you also have to compute the values, how much power consumption should happen. This can be achieved only by using machine learning, where we gather the information or data from those particular locations regarding the season as well as uses, and as well as the maybe the power consumption assumption that can be calculated by using machine learning. This machine learning plays a vital role in making this decision. And now once we make this decision, you can also come up with which type of power should be generation should be used, whether it is a wind or hydrogen or polar, sorry, not polar, solar cell. Because when you see coastal areas, wind, we can go for wind. when we are going for hill areas, we can't go for solar. Mostly wind as well as solar also you can use, but not hydrogen. In urban areas, we can mostly go for hydrogen. We can't go for wind. Depending on those areas and locations, we can decide which one we have to use. And it's not that we have to use only hydrogen for urban or wind for coastal and remote area solar. You can also have a hybrid system depending on the usage type there. If industries are located in urban areas or rural areas, the power consumption will be completely different. Depending on that particular usage only, we have to recategorize that. So you have to create a hybrid system where we can go with wind, solar, hydrogen. All three combination can be used, or any two combination can be used, so that a continuous uninterrupted power can be produced and supplied to the industries or the people that they are living. That's it. Thank you
Good,
very
thank
much
you.
for your insights, sir. From your insights only I have created these slides.
Very good, very good, very good.
Thank you, sir.
So,
If I made any mistake, please sorry, sir.
no, no. I mean, it's really very good to understand that how the participants, they are thinking from different point of view. For example, she thought, yeah, it's okay, it's okay. She thought, let's say, how this machine learning tools can be useful for decision making. So that is a really useful. And that machine learning tools, when we have this unpredictable or intermittent, nature dependent, renewable energy sources, then most of the time, like physics based control system may not be in a position to take the decision. We need to have some prediction. So what her conclusion was that, so machine learning tools can help us in making the appropriate decisions for doing this proper operation of power management within this hybrid energy system. So thank you very much. And then of course, maybe I believe that you are in the academic profession, you can find out some good topics and give it to your graduate and undergraduate and postgraduate students for doing their project work also. So thank you. Anyone among you want to come forward and to share something? Please feel free. Anyone? From the back side, anyone want to say something? Okay, so don't worry. So I will carry on further and I will share with okay, so before the break, I was talking about how we have to do the system architecture to integrate the front end system and the back end system. And I requested, like based on your mind or based on your thoughts, how we can have that architecture. Now here I am going to present you the architecture which have been implemented in this project. Now here you can understand that how this front end system and the back end system, they have been integrated together. In the front end system, we have the home energy management gateway, and here you can see that this home energy management gateway, which is basically of the size of our mobile, it has the operating platform OGEMA, and this gateway basically going to work on controlling the operation of non-critical power intensive load based on the input which it is going to get from the backend system. So in this platform, you can see that we need to have the input output provide drivers also, and of course here we are going to select some of the appliances, those are non-critical power intensive. We cannot select all the appliances. So when we are selecting some of the appliances, let's say we are taking thermal inertia based load or the boiler, in which our complete mathematical modeling or of that boiler will be required, okay, because that boiler has some constraints for minimum operating temperature, maximum operating temperature, its input power, as well as from its output how much water we are consuming. So that modeling is going to be required and going to be integrated in this home energy management gateway. So this home energy management gateway is going to be helpful for the local provisioning also. Now what is going to happen here, you can see this home energy management gateway has to operate based on the schedules which have been received from the backend. So here you can see the schedules are communicated here, and then based on that particular appliances have been covered here. But if you at the same time you can see that here lot of measurements of the system components is going to be there, okay, and that measurements and the reports going to be communicated through some communication medium to the backend system. In the backend system, we are treating as a virtual power plant. So here you can see that continuously this front end system is providing information of the measurements and the reports, let's say, to the backend system, okay, and then backend system is going to use all those measurements and the reports. Then at the same time the information from the home energy management gateway is also sent to the flexibility forecast, because our objective is to do the flexibility, and for doing the flexibility within the distributed network, here we are taking the aggregation of households, right, we need to have the key component that on forecasting. So this flexibility forecast, right, can help us, right, how much energy profile or the load profile of this particular house then getting aggregated is going to be there, and that will be used as an input to this virtual power plant. Now you see here we are talking about one system or one house, but we are going to have n number of houses within that cluster. So here aggregation is also very important. Then based on that, here this SEMIA intelligence or this project intelligence, where I was giving most of my technical focus, that how we have to do the real time scheduling of the loads within on the front end system, but at the same time considering the distributed system operator grid constants. So that grid constants is going to be used here for developing the real time scheduling of the demand side management, and for that then of course we will need some algorithms also. So me and my team, we worked very heavily in developing this algorithm. One was centralized and another was decentralized, and then based on that algorithm, considering the grid constant, taking into the flexibility forecast output, then this virtual power plant can generate the demand side management scenario 1 day ahead or maybe 15 minutes ahead also, and then going to communicate to this home energy management gateway. Now here you can see that how this architecture, like many of you I believe that from computer engineering background, electronics background, so they may be in a better position to understand how this architecture is going to work, right. So this is a very interesting thing. So here on the front end side, when we are getting all this information, like, and this has been processed through this home energy management gateway, and then at the same time we can also have some mobile application also or mobile app in which then we can collect this information from the home energy management gateway to see that how our energy consumption profile is happening and how we are reducing or how we are getting the signals from backend system here and how the user's load profile is happening. Then at the same time, here also one more point, that based on the real time energy pricing, this user may be in a position to know that, because here we are getting the scheduling pattern and we are shifting the operation. So the incentive for the customer is that how much energy bill saving is going to be there, that can be seen through this, let's say, some gateway here. So very interesting to see here. We are having the front end server also, right, where only the local data of that particular house. issue है चार्ज कम हो गया होगा उसका, आई थिंक सो, we'll see. हाँ लगा हुआ है, हो जाएगा आ जाएगा. So anyway, let the laptop get charged or re-energized. We need energy also, so laptop also need energy. So that with that architecture in which you have seen very clearly how that front end system and back end system, they have been integrated together, and how these prediction techniques are going to help to the backend system for taking the decision in developing some demand side management scenario. I think we will wait for few minutes to get it completely charged or some level of the charge. So are you able to understand? And do you think that your thoughts was matching with this architecture? So till it gets fully energized, I will explain you. In this project, 100 houses from Norway and 100 houses from Switzerland, they were selected. Within these 100 houses, home energy management gateway were installed. This home energy management gateway were provided by one of the partner, Devolco Products from Denmark. And in that gateway, Ogema platform from the Fraunhofer Germany was also the partner. That platform have been installed. And using Devolco Products components, Zigbee communication were installed with this boiler load to communicate the information between the gateway and the boiler. And then we have seen the backend system. In the backend system, the virtual power plant was there. That virtual power plant, it was located in Germany. Now you see how the different geographical location were integrated towards towards for doing local demand side management, and that backend system or the virtual power plant, it was operating based on AC microgrid architecture or with AC droop functionality. This virtual power plant was in a position to get the information of renewable energy production in that particular region where the system was connected, if it is any there. Based on that, giving that priority to the renewables, okay, and considering the predicted load profile of this aggregated households and taking into account the grid constraints even at the feeder level, then this backend system used to generate the demand side management scenario, and that demand side management scenario was communicated to the front end system for shifting the operation. So you see how complicated it was, and I have a lot of results on this project also. So let's see how I can share with you. So it is not getting, we will wait for some time. So then second point, which is again very important to you, is that when we are doing this communication of the data, we have to consider security and privacy. The mobile operator which we used in this project, they were saying that the data is quite secure and encrypted. But you might have seen that there was one work package on data security and privacy. We hired one ethical hacker as a postdoc researcher and who worked on this project, and he was in a position to hack the complete system, and using this signal he was in a position to switch off some of the loads of one of my colleagues' house also. So that house was without hot water for couple of days because we were testing that system, and that my colleague, he was on holiday at that time, right. So you see how data security and privacy is going to be important in the smart grid system where we are using information communication technology infrastructure, and that will be required for our machine learning algorithms also. If suppose someone is hacking and injecting the false information, so machine learning techniques or any prediction techniques are going to generate bad scenarios which may impact the operation of such type of system. Is it okay? So then another data security and privacy point was within this OGEMA platform also. When this OGEMA platform, right, basically it is also receiving the information from the backend system, but it has to communicate that information locally where we use ZigBee communication. So we have to see that from local home energy management gateway to this ZigBee component, the data which we are sending or the signals which we are sending both in bidirectional manner, right, how secure it is. If suppose we are using such type of system in any house or in any industry, and if suppose some bad person is there, may be in a position to hack that information and to impact the operation of such type of system. So here the conclusion is that while doing the machine learning techniques, we have to be very careful with reference to the data which we are collecting, whether it is the real data or injected data or hacked data. We will need security and privacy of the users also. If we don't take into account the user's privacy, so that is also not very good, because in Europe or in many of the countries, user privacy is taken on top priority. Good. So now you got the idea that how critical it is, right? So of course, you see how we have to offer the schedules from intelligence to here, then that schedule has to communicate it here also. And then another very interesting thing, that how this information is going to be useful from the transmission system operator point of view for making our network more sustainable also. So I believe that you got some idea from this architecture, right? And here in this project, design and implementation of the flexibility forecast service at Fraunhofer, Germany, and the subsequent integration with the virtual power plant have been done. Okay, so that is a really interesting, and because it needs lot of efforts also, but we have very limited time and diversified participants, right? So it is not that easy just to go in depth on each and every technical point, but you are getting some idea that is important, and then some of these ideas then you may implement through your students, through some project works also. Then another thing which we noticed here, great constraints. While developing this architecture and sending the demand side scenarios in which we need to consider the thresholds at feeder and the household levels also, because every house is having some certain peak demand. So we had to be below the certain peak demand, so that also we need to consider. And then in such type of system where we are using machine learning or forecasting techniques for making the decision, security and privacy going to be very important. That's why there was one dedicated work package on security and privacy also. So in this virtual power plant functionality, first we integrated the built-in stochastic scheduling mechanism. This stochastic scheduling mechanism can be replaced with any other machine learning techniques also. And we made possible that in place of this stochastic scheduling, we can allow the third party schedulers to network with the household clusters and integrate with virtual power plant. So here the front end system and the back end system working constraints and the constraints with virtual power plant. Constraints with virtual power plant is that we have to promote the renewables. At the same time, we have to take into account the conventional power plants constraints, so that this virtual power plant can generate the demand side management scenario using Drup functionality. Okay, so here you can see that what the input data is going to be required for the scheduler for developing probabilistic schedule for each household. So here you can see that the input data which is going to be required, like energy pricing, because I mentioned that is a real time energy pricing is going to be there, grid constant is going to be there. We have to consider in this case probabilistic flexibility forecast. So that information we need in the scheduler also. So in the scheduler, then we can create with the help of the stochastic development scenario constructions and reductions also. Then it may develop n number of scenario. We have to do the optimization of those scenarios also, which scenario is going to be useful. So here you can see that not only creating the scenarios, but we have to optimize them. That also has to be done in by using deterministic optimization process, and then we will do the optimization, and then that optimization can create some schedules for each scenario and n number of schedules, and then that schedule based on those houses, right, going to be communicated to each households. So here you see it is not going to be as simple as we are thinking. And if we go back, for example, here on this slide, if you simple way we think, we have to shift the load here. So just we put some small program and we can do it. But is it like that? No. It is very complicated, and we need to have virtual power plant facility, front integration of front end and back end system, use of ICT infrastructure. We have to take care of the security and privacy, so on and so forth. So that's why you can see that how unique this project it was, in which we received around 3.8 million euro for 3 years period. And in the first 1 year, we worked on developing all these scenarios, okay, and how it is going to be working and like that. And after first year, then we recruited 100 houses in Norway and 100 houses in Switzerland, and then we developed this hardware, and then before implementing that hardware in those houses, we need to do the lab testing also. So that lab testing we did with a partner company Devo team, whether the system is working or not. Then after that, then we implemented or installed that systems in 100 houses in Norway and 100 houses in Switzerland, and then we tested this system. So you can see that how the information exchange which need for the DSO service and data interface started, then basis for data model for grid constraints, data model for flexibility needed, and management interface between the SEMIA scheduler. So here you see that we have this virtual power plant here. This virtual power plant I explained you in the previous slides, let's say, going to communicate algorithms. So scheduling algorithms here, those scheduling algorithms are communicated to these houses. For what purpose? Demand response scheduler. Okay. So here from the prosumer point of view or the consumer point of view, right, we are getting the flexibility and the shifting of our load with reference to the flexibility, right, we are contributing in improving the services of distributed system operator. So this is a very, very interesting project which we have implemented in cooperation with 12 partners which we discussed earlier and implemented in Norway and Switzerland. Now, some of the things which may come in your mind also. I think I'll just, yeah. That every house is going to be a very different consumption profile, different user behavior. Okay, so it is not that easy. Some of the houses may have more leakage of the heat. Some of the houses, they may have been newly built. So for that, to doing more detailed analysis, which we did also, we need to have or we need to do the modeling of that house. So let me see if I can find that one here, if it is there. Yes, it is there. you see, anyway, so you you can see here how this household load categorization which we did, critical load, non-critical load, power intensive non-critical load, water heater, air conditioning, cloth dryer, electric vehicle. Then we developed the model for each unit, okay, with complete flow chart, taking into account all equation, user preference, typical parameters, and so on and so forth, and temperature, demand, different parameters, right? Similarly for the clothing dryer, washing machine, electric vehicles, and so on and so forth. Then defined the critical load, non-critical load. Then we developed this energy management system algorithm, like by defining the user priorities also. And then accordingly, then energy pricing mechanism, time of use, real time pricing, demand charges. Then here you see with reference to different conditions, how much energy saving can be done, which load we have to shift, and so on and so forth. So a lot of work which we did, right? But now we have the limited time, and sometime is difficult for us also to cover all these things, but we have that all that work here. So if in this GIAN course, the objective is that to create your interest in sustainable technology, to use machine learning also, and I believe that we are trying, me and Farooq are trying our best to create that interest in you. Okay. So here that this is a typical example of scalable energy management infrastructure project I am presenting. Then when I said that pilot testing, it was work package 8, how 100 houses were there, 100 houses were in Switzerland. Then how we tested this system for taking into account thermal load and boiler. So then the pilots concluded testing of demand response provided by the SEMIA infrastructure through virtual power plant. So it means that the results what we got through this project is at the TRL level of 8, 7 to 8. Okay, it means that the system which have been developed by using all these components and configuration and like that is available for the industry to take it forward and get it implemented into the market. So that is the TRL level 7 or 8. So now you are, many of you are very young professionals and have a long career to do the research work or further work. So you can think like whatever the research work you want to do, it should have very high TRL level so that industry can get a benefit out of that. So in future, maybe when we will plan any another GIAN course, we will try to integrate some industry together so that we can get some industry inputs also, and we can also provide our academic inputs in creating more industry academia interactive GIAN course. Okay. So in this project, several infrastructure components which you have seen were finalized during the period, and it includes basically the integration of backend and the front end system with grid constants, and the system level testing was conducted alongside the integration of SEMIA infrastructure, and most of the test cases have been successfully passed, and we did some security demonstrations also to see that what are the data security and privacy issues are there in such type of system, and we observed some vulnerabilities and we verified them and mitigated them. So we tested this automated demand system in the first scenario of heating system or the boiler load, both in Norway as well as in the Switzerland, and then we got the feedback from European Union and the reviewers. Like here, you have tested only 100 houses at one region, 100 houses at another region. But if suppose such type of system might have been implemented in thousands of houses, then how it will happen? Then we used the simulator from HESO Switzerland to test this system for more than 200,000 household simulation, how it is going to work. So this is a very interesting project in which we are integrating all engineering disciplines together, including energy economics also, because such type of projects, demand side management is going to impact the revenue generations of the utility company. So they may need to have new business models there. That's why you might have noticed that there was one work package 6 or 7 in which new business models were developed using energy on platform from Switzerland. So now I want to conclude here. We need to have sustainable community, and to have this sustainable community, we need to integrate information communication technology infrastructure. And when we are integrating this ICT infrastructure, lot of data will be collected, including user preferences and the behaviors also. So based on that, then of course it is not easy to make the decision using physics based approach. So for that we need to use machine learning or artificial intelligence based approach. Then only we can move towards the sustainable communities and to achieve our goal of sustainable technology development. So thank you. Do you have any question or any feedback on this project, or what you have learned from this project that I want to see? Anyone among you can come forward and say that what is your learning from this project, because it is a very complicated project and the objective was very small. Objective was just to make the load profile simple or to improve the load factor. But when you have seen all this, right, then you might have noticed that how complicated it is going to be there. And this complication can be overcome through smart grid technologies. And to have the operation of the smart grid technology, we need physics based approach also, but at the same time we have to use machine learning tools for making decisions also. So anyone among yourself want to come forward and to say something on this project? What? Yes, please, 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 please. Yes, this is a very good question. We have seen here demand side management scenario, and this demand side management scenario was basically going to be operate based on the grid constraints or maybe the real time pricing. With reference to the energy storage, if we are going to include into the demand side management, whenever there is a low energy pricing, we can store it, and when there is high energy pricing, we can sell it back also. With reference to this algorithm, what she was saying, so maybe in tomorrow's lecture, I will provide you active microgrid architecture, which we can use in charging and discharging processes of batteries, considering group functionality and those controller, what we will discuss tomorrow maybe, that you can even put it in a chip also and can work it. So that will depend on two situations. One situation where we are using the energy storage as from the energy management point of view, one point. Second point, whether we are using power management point of view, because for both situation, the controller operation is going to be very, very different, right? So in hybrid electric vehicles or in electric vehicles, the management of the batteries are mainly based on power management approach, because we need instantaneous power. And if we consider, let's say, from the domestic applications point of view, then that can be more on energy management approach. Is it okay? And for the batteries, then controller, it will be required bidirectional controller, right? Charging and discharging. In bidirectional controller, if we are using the power management approach, it means that batteries has to contribute to instantaneously deliver the power, not from the energy management point of view. That time, always we have to think like how much reserve in the battery banks we need to keep, so that they can contribute towards the power management service or ancillary services. Okay. So maybe if time permits, in tomorrow's lecture we will discuss. So we need to use some algorithms, and to get that we need to have some prediction also, right? And all the time then we need to estimate using some prediction techniques state of charge level into the energy of the battery. Then only they can contribute in that. And this state of charge, dynamic state of charge condition into the battery analysis is again very challenging. We will need equivalent circuit diagram of the batteries. That equivalent circuit diagram of the batteries is going to be changing all the time due to the degradation of them. Okay, so that is also very interesting research work. Some of the PhD students in my university, they are working on that, and they are using impedance spectroscopy for modeling the battery banks under the different operating condition to know the degradation process also. And that model will be required in doing predictions of the available energy within that battery with reference to the time for contributing towards the power management, not on the energy management, mainly on the power management. Is it okay? Anyone? Anyone had any question, discussion? So now I will give floor to Farooq. Want to say something, Farooq? So we don't have the time. Otherwise, I have very interesting work on electric vehicle fast charging station. Okay, charging resources management. That work is really, really unique. But we don't have the time. So let's say time permits tomorrow, then we will discuss on that. But briefly, I will explain you briefly, okay? Maybe this one, but briefly, okay? And then you can see one of my PhD student, he completed the PhD on this topic, okay? I will explain briefly, okay? When we have this fast electric vehicle fast charging station, okay? And here the vehicles, they will come. We are not going inside the vehicle. We want to provide the energy to these vehicles. And we never know the vehicle which will come to our station, how much charging requirement will be there. what type of electric vehicles will be there. And when they are coming at that time, we don't know how much grid constraint is going to be there. To do this charging management at the fast charging station, that one of my PhD student, he completed this task in which probabilistic distribution of electric vehicles which can come at that particular station, taking into account the typical driving patterns, have been carried out. And when the vehicles they are coming, some vehicles they may say that I want to pay more, but I want to get fast charge. Someone may say that I want to pay less, but I want to have longer charging also. So all those factors, you see, have been taken into account in this project, and all these parameters basically we need to predict for economical and sustainable operation of such type of system. So all complete mathematical modeling of this work is available in the articles related to these topics, and most of the articles they are open access. If you have interest in this work, I request you to go through them. Okay, then you will get the idea, right, in how we can use this prediction techniques, probabilistic methods for optimizing the charging requirement of heterogeneous electric vehicle users with different priorities, with the objective of customer satisfaction and making the profit. That was the key focus of that work. It was 3.5 years PhD work, and I just explained you in 2 or 3 lines basically. If suppose anyone among you is interested in doing research work related to this topic, please feel free to discuss with me. Okay, so this is also a very interesting work. Then another work maybe I would like to show you. This is basically related to this SEMIA project, what I was explaining you. Here we have much more detailed modeling and everything. So here you can see that water heater model, how it has been developed. Okay, of course, all these parameters and then taking into account those have been implemented as a driver in this OGEMA platform. Okay, because we need that one information. Similarly, then we used model for the cloth dryer also. Similarly, we used model for electric vehicles also, and then we developed this EMS algorithm by taking into account different for doing the aggregation houses, because we have very different type of houses, different type of living conditions, different type of economical conditions also. But such type of approach can be implemented in industrial load, okay, or maybe in institutional load also. So how do you think, what modifications can be implemented in this architecture? Want to implement demand side management scheme in industrial load, for example, or maybe institutional energy system. Now you got the question? Anyone want to say something? Feel free, okay? Because we are at the end of the today's session, so I know many of you are tired also, including me. Yes. Correct. No, it is engineering type na, because mainly engineering, because we have the load in industry, and some of the load, those are critical load that always we need to fulfill, and we have to reduce the demand from the main grid also. So we may have the distributed generation also. That distributed generation can be renewable based also, or maybe combined heat and power plant also. So that operation of distributed generation plant and the economics is going to be based on engineering analysis only. Yeah. So basically, correct, correct. So we have to make a proper engineering evaluation, engineering analysis or technical economical evaluation first, and then we have to see that how we can get it implemented and how we can convince the management. Yeah, but now due to this corporate social responsibility and commitment of India's by 2070 carbon neutral, and by 2030 they want to have 3 times more renewables, right? So naturally then they have to increase installations of renewables, and to manage that then we will need this data driven techniques. Maybe today I am tired, but tomorrow I will explain you how we can do that one. Okay. So do anyone is having any question or anything like that? Just feel free to ask, okay? Because I am speaking continuously, but now is your turn also. Yes, please. What, repeat again? That's really a very good point here. I will explain you in a very simple manner. Let's say our system is having some demand with reference to the time. Let's say it is going in the steady state situation first, constant. But all of a sudden, due to some transients, load transients, or maybe the renewals, there may be sudden fluctuations. Correct? This sudden fluctuation is going to happening within a fraction of seconds of time. Within fraction of seconds of time. If this fluctuation which may happen, let's say, is between less than 3 seconds of time, our battery system may not be in a position to respond at this short period of time. So, to respond this short period of time, we have to use capability of high capacity generator. This capability of high capacity generator is going to help us in overcoming these transients. Now, question is, our system is running perfectly, but all of a sudden we have some fault, or maybe increase in renewables, or maybe some change in the load, right? So, this information which we are collecting, it is at a very fraction of seconds of time. If we are not able to rectify that information within a fraction of seconds of time, our system may collapse. And to avoid the collapse of the system, we are doing continuous real-time monitoring of the system parameters. Correct? So, this real-time monitoring of the system parameters, it may be at different location. We are using synchrophasors for that one. But at the same time, if suppose someone is in a position to inject this data, creating this scenario, then the capability of this system is going to be changed, or operational capability of the system is going to be impacted due to these changes. So, that is why this data security and privacy is becoming very important in sustainable operation of our energy system. Now, you see, I just mentioned for less than 3 seconds of time. To overcome these changes, like within the 3 seconds of time, the system is going to. But if we put wrong information here, right, and if it gets this one, it will collapse. And to do this analysis in real time, we have to use data analysis. And we have to see that if it is a false injected data or the real data, and for that, then we have to use some regression tools also. So, this is a very interesting point what Amin asked, like regarding the safety or the fault in the industrial system, especially when we are taking very few seconds of time. Any other further points? If not, then maybe we can have a cup of coffee. Is it okay? Good. कॉफी ले लेते हैं क्या बोलते कुछ और देना है ब्रेक दे कॉफी का अपन वहाँ पे कल का दिन नहीं 37 रात को कर देंगे अभी कर देंगे